we have complex fraction. So first we have to check if we can do some operations in numerator and then in denominator. Because we cannot reduce anything here because we have additions, the same will be with denominator. So first I will rewrite our numerator and denominator, and I will change fraction bar for division because fraction bar means division. So this is equal, we have 12a cube plus 19a square plus 5a over 4a square plus 20a plus 25, and we have division sign, and in numerator we have 6a square plus 11a plus 3 over 8a square minus 2a minus 21. Now we have division of two algebraic fractions, so we have to copy first fraction, 12a cube plus 19a square plus 5a over 4a square plus 20a plus 25, and we have times. Now we change division sign to times, and we have to flip the second fractions. So it will be 8a square minus 2a minus 21 over 6a square plus 11a plus 3. Next, how we multiply algebraic fractions? We multiply numerator times numerator, denominator times denominator. And what else we can do? We can factorize a from the first numerator. So it will be a times 12a square plus 19a plus 5, and in second parenthesis we will have 8a square minus 2a minus 21 over, and in denominator we have 4a square plus 20a plus 25 times 6a square plus 11a plus 3. At that moment we see that in parentheses we have different expressions, so we have to try to factorize. So we have quadratic trinomial in the first parenthesis, so we will try to use grouping method to factorize this. Let me copy this expression. We have 12a square plus 19a plus 5. So because coefficient before a square is different than 1, so I have to multiply 12 times constant 5, so this is 60, and now I have to find two numbers which I multiply and will be 60, and when I add these two numbers I will have coefficient before a is 19, so it will be 4 and 15. So now I have to copy first expression, and 19a I will rewrite using these two numbers which I got, so it will be plus 4a plus 15a. Doesn't matter if you put first 15 or 4, you will get still the same at the end, plus constant. So this is equal. Now we can factorize 4a from the first two expressions, so will be 3a plus 1, and from last two I will factorize 5, so will be 3a plus 1. Now we can factorize 3a plus 1 because we have the same terms in parentheses, and we will have 4a plus 5 in the second parenthesis, whatever left, 4a plus 5. Next, we have to try to factorize the second expression in the parentheses. So let me copy this. We have 8a squared minus 2a minus 21. So we have to first multiplying coefficient before a squared times constant negative 21. So this is equal negative 168. So now I have to find two numbers which I multiply, and I will have negative 168. And when I add these two numbers, I will have coefficient before a is negative 2. So it will be negative 14 and 12. So now we can rewrite our quadratic trinomial. First expression we have to copy, and negative 2a now we will rewrite using these two numbers which we found. So it will be negative 14a plus 12a minus 21. So this is equal. From the first two expressions we can factorize 2a, and in parentheses we will have 4a minus 7, and from the last we will factorize 3, so it will be 4a minus 7. So now this is equal, we can factorize 4a minus 7, and in parentheses will be whatever left. So we have 2a plus 3. So now we can look to our next expression. We have 4a plus 20a plus 25. Let me copy this term. So 4a squared plus 20a plus 25. We can rewrite 4a squared, that this is 2a to the second power, and 20 we can rewrite that this is 2 times 2a times 5, and 25, that this is 5 to second power. So now we see that we can rewrite that this is equal 2a plus 5 to second power, the square of sum. Let me remind you this formula. When we have x plus y to second power, this is equal x squared plus 2xy plus y squared. In our example, x is equal to a and y is equal 5. We have exactly 2, the same like in our formula, and next is x times y, 2a times 5, exactly the same. So we can rewrite the first expression in the parentheses in denominator, that this is 2a plus 5 to second power. And the last term we have 6a squared plus 11a plus 3. So first we have to multiply coefficient before a squared 6 times constant is 3, so this is equal 18. So we need to find two numbers which I multiply, and I will have 18, and when I add these two numbers I will have coefficient before a is 11, so it will be 2 and 9, of course, because 2 times 9 is 18 and 2 plus 9 is 11. So now we can rewrite our quadratic trinomial. 6a squared we copy, and next 11a we can rewrite using these two numbers, so will be plus 2a plus 9a, and we have to add constant, so this is equal. Now we can factorize from first two terms 2a, and in parentheses we will have 3a plus 1, and from the last two terms I can factorize 3, and in parentheses we will have 3a plus 1. So this is equal. We can factorize 3a plus 1 because in parentheses we have these terms, and whatever left will be in the second parenthesis, so it will be 2a plus 3. So now we can rewrite our algebraic fraction we have to copy A. Next, first term in parentheses we'll substitute by this expression. So we have 3a plus 1 times 4a plus 5. Next term we factorize. This is equal to that term. And denominator, first term, we can substitute by 2a plus 5 to second power, and the last term is equal to that term. So we have 3a plus 1 times 2a plus 3. Now we can check if we have the like terms. In parentheses we have 2a plus 3 and 2a plus 3, so we can cancel out. We have 3a plus 1 and 3a plus 1. So now in the numerator we have a times 4a plus 5 times 4a minus 7 over we have 2a plus 5 to second power. This is my solution.